All right, guys, any questions over the homework before we get started? Just 2-2 and 2-1 are the two assignments so far. Number 15? From 2-2? You possibly, let's see here. You have it right there. Problem number 15 from 2.2. Now we're given the equation y equals negative x times x plus 6. We want to find the x-intercepts, our vertex, and the axis of symmetry. Now the y-intercepts of the axis of symmetry are going to be 0, 0. So our three values that we needed or we were looking at were P, Q, and A. All right, guys, let's focus in. Now, Q, one of the two values is kind of easy to find, our x plus 6, we would get negative 6. Now, the other value, because in the general form, it's A times x minus P times x minus Q. We see the Q does line up with our 6, and that's where we get the negative 6 from. Now, since there's no set of parentheses here with our first x, the value for P is actually going to be 0, and A is going to be negative 1. So because there wasn't a set of parentheses there, that value of P is actually going to be 0. So that means our intercepts are going to be 0, 0, and negative 6, 0. So it's going to cross the x-axis at 0, 0, and negative 6, 0. Now the vertex in the general form was P plus Q over 2, comma F plus P, F of P plus Q over 2. Now our P and Q values, one is 0 and the other is negative 6. So we're saying 0 plus negative 6 over 2, which is just negative 6 over 2 or negative 3. So the x value of the vertex is negative 3. It also gives us the equation for axis of symmetry. Because our equation for axis of symmetry was x is equal to P plus Q over 2. Now the last thing we need to do is find the y value of the vertex, and to do that, we're just going to plug negative 3 back into our equation. So we would have negative 3 times negative 3 plus 6. Well, our negative 3 is just going to be 3. Negative 3 plus 6 is 3, and 3 times 3 is 9. So that there would be our answer. I think the question was really finding that other value of P. Yeah. Any other questions on the 2-2 homework? Okay. So what we're continuing on with is finding these equations of the parabola in the standard form from the given information. Now we are told the vertex is the point negative 1, 4, and the focus is the point negative 1, 2. Now no matter which of the two forms we have, the vertex is always going to be the point H, comma, K. That is the vertex. That is just stated for either one. Vertex is H, comma, K. Now our focus comes in one of two forms. It's either H, comma, K plus P or H plus P, comma, K. That value of P, that plus P, is going to go with whichever number in the focus that changed from the vertex. So if we look at the two numbers in the vertex, we have negative 1, 4. The focus is the point negative 1, 2. So the first or second value, which one of these changed? The y value, that second value, yes? So that tells us that the focus has to be in the general form of h comma k plus p. We put the p value with the second one because that's the one that changed from the vertex. Questions on this here? Vertex is h comma k. Since the second value changed, that's the one that gets the p, so it'd be k plus p. So that does tell us where we can find p, how we can find the value of p. It also tells us which of the two equations we're using. Because the one that matches up with the focus of h comma k plus p is our y equals a times x minus h squared plus k. And again, the four values, or the four things we're looking for is the value of h, k, p, and a. And the main reason we need to find the value of p is to find the value of a that we plug in. Well, the vertex told us what h was. H is -1. K is 4. We have h and k, -1 and 4. Now, we don't have the value of p. But I do know, what, that k plus p is what? 2. According to the focus is h comma k plus p. K plus p is 2. We know what the value of k is. K is what? 4. So we're saying 4 plus whatever p is will give us 2. Yes, indeed. We would subtract 4 from both sides, telling us the value of p is -2. 1/4p, because again, we need to find a to plug it in, and that'd be 1/4 times -2. We can plug that into a calculator. We can do it by hand. Either way, we'll get the fact that a is -1/8. Questions on how we found h, k, p, or a? Now we just need to plug it back in. So we say y equals. So we'll replace a with -1/8. X minus our h value is -1. Yes. Because our -1, we don't have to leave it as -1. We could just rewrite that as +1. Telling us our equation is y is equal to -1/8 times our x plus 1 squared plus 4. Questions on this here? We ready for the next one? Now this one here gave us the vertex and the directrix. Now directrix, I said yesterday, was kind of nice because when we look at the two directrix equations that we have, for our y equals equation, it's y equals k minus p. Y equals a number. For our x equals equations, its directrix is x equals h minus p. X equals a number. So the nice thing with directrix, it tells us immediately which one we have, because it's either going to be in the form of x equals or y equals. Here, the directrix is y equals 73/8. Well, the only one of those two equations that has a directrix of y equals is our y equals k minus p. Which goes along with our y equals a times x minus h squared plus k. We just match the two equations together. And again, we're looking for the values of k, h, p, and And for these here, since we're going to the equation, we need to find P in order to find A so we can plug it in. Vertex is still the point what? H comma K. So the value of H is 8, value of K is 9. Value of P, well, we don't quite know the value of P yet. We have to find it. Directrix, general form Y equals K minus P. And it's told to us that the directrix is 73 over 8. And we also know that the value of K is 9. So we're saying that 9 minus P is equal to 73 over 8. So what do we need to do first? Minus 9 from both sides, telling us that negative P is equal to, well, 73 over 8 minus 9 is positive 1/8. Well, we can't stop there because we don't have P equals a number, we have negative P. So how can we fix that negative sign? We can divide it by a negative. What negative? Negative 1. Because negative P divided by negative 1 is P. 1/8 divided by 1 would be 1/8. But because we're dividing it by negative 1, it's going to be negative 1/8. Do you know we could have also multiplied by negative 1 and got to the same spot? Because negative P times negative 1, the negative and negative make positive. 1 times P is P. 1/8 times negative 1. 1/8 times 1 is still 1/8. And our positive times a negative would make it negative. We get to the same spot. So we found that the value of P is negative 1/8. So the last thing we need to find is the value of A. And A is equal to 1 over 4 P. So we have 1 over 4 times negative 1/8. Yes? And up to this point, the largest value we've had for A was 1, yes? I mean, positive or negative. And as I've said, we can have values bigger than it, because here, the value of A is negative 2. So Y equals negative 2 times x minus 8 squared plus 9. And again, when we plug H and K back in, make sure we're plugging them in the right spots. For Y equals, H is inside the parentheses, K is outside. Our other equation, X equals, K is inside the parentheses, and H is on the outside. So again, I would keep making sure we're plugging them in the right spot. Questions on this here? Okay, that's fine. And hopefully by this point we're seeing how the given information relates to our H, K, P, and A, and how we can use those values to get the equation. So that's all we're trying to do, is find these values and plug them into their corresponding spots. Yes. We good? All right. So let's look at this next one here. So we are given the focus and the vertex. So the vertex is negative 8, negative 9. The focus is negative 31/4, comma negative 9. So which one of the two values changed? The first or second? The first, because I don't have, as I have an H value of negative 8 in the vertex, but I don't have an h value of -8 for the focus, which means we had to add or something to it. We added some value of p. So vertex is still hk. It means this focus has to be h plus p comma k. Because our k value is -9 for the vertex, focus it's still -9. Didn't do anything to it. But that also tells us that our general equation for this here is our x is equal to a times y minus k squared plus h. Our value of h is -8. Our value of k is -9. And we know that p, well, h plus p is -31 over 4. Does it really make a difference what h plus p is? No, it doesn't change what we do. If it's a fraction, if it's a whole number, it's an integer, we still do the same process, yes? So again, lining them up. H plus p equals, because what it is, because h plus p, whatever value of p is, we're going to add it to h to get -31 over 4. One that we add the p to, yes. Because if the y value changed from the vertex to focus, we use k plus p equals that amount. Since the x value changed from vertex to focus, we use h plus p. Then we can plug in the value of h, which is -8. So h plus whatever that value of p is should give us -31 over 4. At this point here, we can do what? Add 8 to both sides. I think it should be 1/4. So, we feel good about finding p? Yes? All right, guys. We feel good about finding the value of p? Okay. So we get -8 plus p equals -31 over 4. We added 8 to both sides and got p is 1/4. Then to find a, we take that value p, plug it into our 1 over 4p, which gives us 1 over 4 times 1/4, which will give us. Now we can plug it back in. A is 1 minus k, so minus -9, plus -8. But we're not going to write it as x equals 1 times y minus -9 squared plus -8. Our negative and negative make a plus, and our plus minus would give us negative. So we just get x equals y plus 9 squared minus 8. Questions on these here? I think we feel pretty good with these here so far, yes? Feel comfortable with this, finding h, k, p, a, and how we line these up, connect these out, yes? We ready for the next one? So if we look at this one here, it gave us the directrix. Directrix is nice because it immediately tells us which one of the two equations we have, yes? So since it has directrix as x equals, well, general form for that, x is equal to h minus p. That also tells us that our general equation is x equals a times y minus k squared plus h. And we still need to find the values of h, k, p, and a, yes? So we can find the value of p from the directrix h minus p because it tells us its value, yes? And since it gave us the vertex, our values of h and k are. Did it give us the vertex? What did it give us? The focus. Now, at this point here, especially in all the problems we've done so far, we had to look at what changed from the vertex to the focus to figure out which one we have, yes? Directrix already told us which equation we have. The equation we have is our x equals equation, yes? Which means we also know the focus is what? H plus p, comma, k. And this here is the hardest of all the setups because it adds one step. That's all that makes it anything different. Because if we look at this here, directrix told us that h minus p is negative 65 over 8. Whatever h and p are, when we subtract them, we get negative 65 over 8. According to the focus, when I take the value of h and add it to the value of p, I get negative 63 over 8. So we are able to find the values of h and p. We're just going to have to do one step in the middle to get there. But out of all this here, it did tell me what k was. K is negative 7. Questions on what we've done so far? Because really all we've done so far is use the directrix to be able to tell which one of these two equations we have. And then I use just the definition of the directrix, x equals h minus p, to say that h minus p, whatever the value of h and p are, gives us negative 65 over 8. According to the general form, our focus, h plus p, should be negative 63 over 8. And we know k is negative 7. Yes? What we've done in setting all this up is we've actually made a system of equations. H plus p, h minus p. And we're going to use this to find the value of h, and then use one of those two equations to find the value of p. Now, the nice thing with this, unlike most systems of equations, we have to get one of the two values to have the same number in front of it, yes? Well, no matter how we set this up, one of them, both of them are always going to be the same because it's either h plus p, h minus p, k plus p, k minus p. So at this point here, you just have to make the choice. We have to make the choice. Do we want to add or subtract? Say we choose to add these two equations together. And we're going to add. What is h plus h? 2h. What is p plus negative p? 1 plus negative 1. 0. The values of p would cancel out. Now that does give us negative 65/8 plus negative 63/8. I would just take it, stick that right in the calculator, let it deal with that for us. Because negative 65/8 plus negative 63/8 is negative 16. Solve for h. We would divide both sides by 2, telling us h is negative 8. So when we're given the focus in the directrix, it adds this step of setting these two equations up, h minus p, h plus p, And you can add them together. You'll find the value of h. If you subtracted them, you'd find the value of p, because h minus h is 0. Our negative p minus p would be negative 2p. It's all from there. Now that we have h, we can actually find the value of p. Now, which equation you pick does not matter. Because if we picked h plus p, h plus p is going to equal negative 63/8. That's just according to the focus. We know the value of h now is negative 8. So we're saying negative 8 plus p is negative 63/8. At this point here, we can do what? Add 8 to both sides. So negative 63 over 8 plus 8 is 1/8. And then once we find the value of p, we find the value of a by plugging it into our 1 over 4p. 1 over 4 times 1/8, which is 2. Questions on how we found h, k, p, or a? Would we say this added a whole lot of extra stuff to this? A little bit. Added an extra few steps, but I wouldn't say it made it too much harder than what we've been doing. Because we added that one step, we set the two equations up, we add them. We get our value of h. We use it to find p, we use p to find a, and now the last thing we have to do is plug it back in. We're going to replace a with 2. We're going to replace k with negative 7, and instead of writing y minus negative 7, we're just going to write it as y plus 7, and our value of h is negative 8. So instead of writing plus negative 8, we can just say minus 8. Questions on this here? Let's look at another one of these here. Now they give us the focus in the directrix. Directrix x equals, so the general form for this here would be x equals h minus p, because that's the only equation that actually has that in its setup as a part of its properties, which also tells us that our general form is x equals a times y minus k squared plus h. It also tells us that the focus's general form is h plus p, comma, k. Now our values of h, k, p, and a, we are going to need to find. Now it didn't give us h, it didn't give us p. The only value that when we're given the directrix and focus actually gave us for this one here is k. K is -7. When we were given the directrix in focus for our y equals equation, it won't give us k or p. It'll only give us h. We'll only get one out of those three that we need. But we can use these general forms to find h and p. Because I know that h plus p is equal to 107 over 12. And I know that h minus p is equal to 109 over 12. So h plus p is 107 over 12. H minus p is 109 over 12. Questions on how we set any of this up, or how we've done any of this so far? So to find the value of h or p, we need to set these two up, and then we need to add or subtract. Do we want to add or subtract? Add. We can just add. So if we add these two together, h plus h is 2h. P plus negative p is 0. So now we just need to do 107 over 12 plus 109 over 12. Is 18. At this point here, we can divide both sides by 2 minus h is equal to 9. Personally, I end up using h plus p instead of h minus p, mainly because with h minus p, we have to deal with that negative p. We have to fix that. We have to multiply or divide by -1. H plus p, we don't have that issue. So it's a little bit easier to work with. Value of h is 9. So 9 plus p is equal to 107 over 12. At this point here, we will subtract 9 from both sides. So 107 over 12 minus 9 is -1/12. Now the last thing we're missing is the value of a. And a is equal to 1 over 4 p. Our value p is -1/12. 1 over 4 times -1/12 is -3. So that's telling us x is equal to -3 times y minus k. So for us here, that'd be y minus -7, but we're not going to write minus negative. We're just going to write it as a plus h, giving us plus 9. Questions on these here? I think at this point we're getting the hang of how we find the values of h, k, a, and p, and being able to take those values from the given information, our vertex directrix, vertex focus, directrix focus. Directrix and focus is going to most likely be one of our bonus problems on the test, finding the equation from that given information, and working our way to the equation. Now, the only other piece we have with this, because we're not going to get through all of these today, but it's taking the equation and going back to our vertex, focus, directrix, and axis of symmetry. And as we look at this equation, there is more written on your paper than mine. I took that piece out. There is a few things that are nicer. One, they gave us the equation here, y equals 1/8 times x minus 3 squared plus 2. Well, I know that the general form has to match up to it. Since we have y equals and x inside the parentheses, that means the general form has to be our y equals a times x minus h squared plus k. We match those up. Now this here, just like our ones we've been doing, we still need to find the values of h, k, a, and p. Now, unlike from the vertex, directrix, focus that gave us p, and we use p to find a, this one time we're given a, and we'll need it to find p. Is h, k, a, and p. So looking at this here, what's the value of k in this equation? 2. What's the value of a? 1/8. What's the value of h? Positive 3. Because since it's inside the parentheses, we have that x minus h. In the equation, they gave us x minus 3. X's line up, minus line up, so h has to be positive 3. Well, what's the only value we're missing? P. And according to our equation, P is equal to 1/4A. A is equal to 1/4P. P is equal to 1/4A. So we have 1/4 times 1/8. And we can stick that in a calculator, let the calculator do that for us. And it'll tell us that the value of P is 2. So we want to find the vertex, focus, directrix, and axis of symmetry. And again, I would continue to refer back to the general forms. Since we have y equals, the vertex is nice. Vertex is still just h comma k. Well, our value of h is 3. Our value of k is 2. Nice and easy. We have it there. Focus is h comma k plus p. That's just according to the general form. We know what h is. H is 3. Do we know what k plus p is? 4. Because k plus p, it wasn't told to us directly, but I know k is 2, p is 2, so 2 plus 2 is 4. Doesn't take too much for us to be able to just add k and p together and get 4. Directrix is our y equals k minus p. So we can do the same thing. K minus p is 2 minus 2, which is 0. And lastly, the axis of symmetry, x equals h. Well, h is 3. So really, to go from the equation back to our given information, the vertex, focus, directrix, and axis of symmetry, we still need to find what? The values of H, K, A, and P, and plug them into their corresponding spots and simplify where needed. Questions on those here? How many of y'all like finding these 4 pieces of information better than the equation? It's a lot easier. There's a lot less that we have to do. It gave us pretty much everything. We'll finish this tomorrow.